Um, Thank you for actually liking and thank you for commenting. Thank you for the subscription. I so much appreciate every one of you. So, but today we have some problems as well to actually look into. And God so good, we are going to solve just one out of the two. And I'm giving you the second one as a bonus. So whoever gets the answer, the first person to get this answer gets something from me in return. So this will just be more or less like a challenge for you. So whoever gets the answers first, whoever posts the answer first, whoever comments the answer on my page first, gets something from me. But so quickly, let's see how we can actually solve the problem we have on the board here. Though these are literally simple questions, simple indicial problems. Yes, I can tell you categorically, these are simple indicial equations. We have the difficult ones, but I don't want to put us in a tight corner. Being that we are doing this for the sake of every student, probably student in SS1, 2, and student in 100 level. But if you are ready or if you want harder or more difficult problem on initial equation, you can actually message me directly to get those questions. So let me quickly see how we can actually attempt questions like this. First of all, let's see how can we solve the problem given to us. Remember that we have been told that if x over y is equals to z over w, we are now asked to show that this is equal to this. So shall we show that? Now, first of all, how do we go about showing this? Let's assume x over y equals z over w is k, for example. You can assume it's any alphabet of your choice. I only picked k because I chose k to be my point of interest. So I'm choosing k. You can choose any alphabet of your choice. So decide the fact that I chose k, let's see what we can actually do from there. So that means x over y is equal to k in one sense. Likewise, z over w is equal to k. Do you agree with me? No fact. So that means if x over y is k, z over w is k, then we can clearly have that x is equal to yk or ky. And we can as well have that z is equal to kw. So that means we are going to come to this part here. Anywhere we see x, we replace with yk. Anywhere we see z, we replace with kw. Let's see what we end up having at the end of the day. So we end up having x instead of x now. So we are going to be having, instead of x now, you replace with yk. So we have yk all raised to the power of m plus y raised power m plus, instead of z, you replace with kw raised power m plus w raised power m all over. I believe you understood what I have done serially here. All I did was clinical substitution. I substitute every x with yk. I substitute every z with kw. And so I end up having this. Now let's deal with the denominator. So instead of x now, I chose to replace with yk. Instead of z, I chose to replace with kw. And so what next? You realize that this one are very simple. This is a very simple make sure you are observing this. Now you should know that this one here is the same thing as y raised power m, k raised power m is the same thing. So instead of, I will actually jump a step here because of our time. So in this place now, since I have actually, or since this one has resulted into something like this, automatically I will realize, or you realize that there are common terms here. What's common? Y raised power m is a common term. So if I bring out y raised power m, I want to factorize this expression. If I bring out y raised power m, I'll be left with k raised power m plus 1. No doubt. Plus, look at this one, the same thing. This one will be the same thing as k raised power w, w raised power m. So likewise, if you consider this and this, w raised power m is a common term as well. Then you'll be left with k raised power w plus 1. Sorry, k raised power m rather. Plus 1 all over. Now do the same thing here. You will realize that y raised power minus m is a common term. And so we end up having this. We are going to have y, or sorry, rather k raised power minus m plus 1 Very simple. Just plus, if you realize, w raised power minus m is as well common. Then you have k raised power minus m plus 1 as well. So, and from this thing here, if you actually do your proper simplification, you end up having this as an answer. You end up having y raised power m plus w raised power m into k raised power m plus 1 all over this y raised power minus m plus w raised power minus m into k raised power minus m plus 1. Yes, no doubt. So from here, how do we end up finishing this now? How do we end up finishing this? For the sake of the space, I will have to clean this part of the board in order to complete my solution. So in this case now, remember this was what we end up having. K raised power m plus 1 all over y raised power minus m plus w raised power minus m into k raised power minus m plus 1. So in this case now, you will realize that looking at this solution here, did you know that this one is the same thing, or this expression as a whole is the same thing as y raised power m plus w raised power m into k raised power m plus 1, and this whole one here is the same thing as 1 over y raised power m. Yes, this thing is pronounced y raised power minus m, or rather you can say the inverse of y raised power m. And you are familiar with the concept of inverse. Inverse of a is 1 over a. Inverse of a raised power m is 1 over a raised power m. Inverse of a d is 1 over a d. So looking at it, applying it here, you end up having this I am showing you now. The same thing applies to this. And apply the same thing as well to this. You have 1 over k raised power m plus 1. So if you look at this one now, if you decide to find your LCM and do the proper simplification, let me quickly show you that. You have k raised power m plus 1 all over. Then you will realize that y raised power m, w raised power m is the LCM of this one here. So we are going to be having y raised power m, w raised power m into y raised power m plus w raised power m. When you find the LCM, how many y raised power m will you see in this w raised power m? Multiply it with this one, you get this. These are simple listing. Then multiply by, do the same thing there. You have k raised power m into k raised power m plus 1. And so this one end up giving you y raised power m, w raised power m. Are you with me? Into y raised power m plus w raised power m into k raised power m plus 1 into k raised power m. Yes, the denominator is going to multiply this. These are little simplification. And we are having y raised power m plus w raised power m into k raised power m plus 1. And so this cancels this, and we are left with y raised power m, w raised power m, and k raised power m at the end of the day. But remember where we are going to. This is where we are actually heading to. So how do we get to this end point here? What's our aim? How do we get this? Now, do you know? Let's quickly simplify this and see what we have. So remember the answer we are getting, or we have gotten here. The whole of this has become y raised to the power of m, w raised to the power of m, k raised to the power of m. Now let's now see if they actually average or result to being the same thing. Yes. Take note of what I am doing now. So you will realize that, let's pick up that answer here. We have x, y, z, w exponent m over 2. Now, do you know, always remember that I told you that x is ky and z is kw. Take note of those things. That means anywhere we see x and z, we replace with, anywhere we see x, we replace with ky. Anywhere we see z, we replace with kw. So if we do that, we end up having ky times y. That's x is ky multiplied by the y. times z. My z is kw times the w itself, raised power m over 2. And this one end up giving us y times y is y squared. K times k is k squared. W times w is w squared, raised power m over 2. If you end up, remember the theorem that says, or the law that says, a raised power m into n is a raised power m times n. So if we apply it here, we end up having y raised power ykw all into 2 times m over 2, which will end up giving us ykw all into n, which is averagely the same thing as our. So you will realize that this was our aim. So we have actually been able to solve the problem. We have actually been able to show that this is equal to this. So this brings us to the end of this very, to the solution of this very question here. So like I've told you, I've given you the other questions to solve. Whoever got the answer first receives something from me. Thank you. So I promised everyone that I will actually be taking us through the concept of calculus, particularly differential and integral calculus. But people were raising alarms that I should actually first discuss limits. Though I believe the journey of calculus has something to do with limits. But I have decided that whoever is going to learn limits, or whoever does not understand the concept of limits, should actually message me directly, so I can actually have a personal or what kind of thing with them. So, but in this, I just want to quickly chip in some things on limits, and after then we'll move down to some phases of things. So we have problems on the board here. So we have problem relating limits and continuity, but probably I'll be discussing the concept of limit only. So let's look at this limit here. We are given an example. The question says the limit where x takes to 2 of x squared minus 2x minus 3, that we should simplify. So how do we get an answer to this? How do we solve this problem here? Yes, very simple. There are some rules, there are some properties of limit that we need to understand. Whoever does not understand the properties of limit should consult or actually message me, so that we can actually discuss some of them, so that you can at least understand some of the properties. There are some properties associated with limit in question, but averagely we will just talk briefly about this one here in order to minimize our time. So look at this problem here. Averagely, you don't really need the concept of properties of limit in this. It's a very straightforward problem, though you need the basic properties. So this one is very straightforward and can be done very easy at your ease. So how can we solve this? Now, in one word, all you need to do is substitute whichever value, whatever x, wherever you are finding x here, substitute x to be 2 in one question here. So anywhere I see x, I'm going to replace with 2. Shall we go? So I'll be having, instead of x squared now, I'll replace x with 2. I have 2 squared minus 2 again. So instead of x now, in place of x, I will replace with 2 again, minus 3. And I end up having 2 squared is 4. Minus 4, 2 times 2 is a 4 minus 3. And that gives me 4 minus 4 is a 0. Minus 3 is a minus 3. So the limit of x take to 2 of x squared minus 2x minus 3 is sum up to what? Minus 3. So let's actually find an answer to the second problem. That's problem 1. Problem 2. The limit where x take to negative 1 of x squared minus 1 over x plus 1. Now, if you look at this problem now, if you actually substitute for x is equals to minus 1, then you'll be having probably something like minus 1 squared. Then you'll be getting something like something over 0, which is undefined. You understand? Though I'm still going to take you through some journeys or some rules that will help you when solving problems like this. Problems like this can be solved using different methods. There is a rule known as L'Hopital rules. We are going to discuss that one too. But let's actually solve this one. We can solve this without the L'Hopital rules. Now take note or begin to pay attention. So in this, how do we solve this one now? Remember, I told you if you substitute x to be minus 1, this is what you end up getting. You get an undefined answer. So, but believe me, there are ways we can actually do this. If you observe the numerator very well, the numerator pronounced s squared minus 1. Remember in your primary, your GSS, your SS level, you have discussed something of the form difference of two squares. If we have a square and their difference, something like a squared minus s squared, remember this can be rewritten as a minus x, a plus x. But how do we now turn this to this? Remember that s squared minus 1 is the same thing as s squared minus 1 squared, because 1 squared end up giving me 1. So that means we can write this one as x minus 1, x plus 1. Yes. So automatically I can replace s squared minus 1 with this. By so replacing it with that, I'll be having limits where s take to -1 of x minus 1, x plus 1 all over x plus 1. So x plus 1 cancels x plus 1, and I'll be having the limit where s take to -1 of x minus 1 becomes, anywhere you see x replaced with -1, you have -1 minus 1, which is a -2. I believe there's no problem with that. Look at the third problem. Yes, the third problem requires you to actually limit. The third problem, you can actually solve that one. Limit where s take to 3. The third problem requires you to simplify before substituting. There are some problems. If you actually substitute x to be 3 here too, you will end up having something in the form undefined as well. Because when x is 3, you have 3 minus 3, that's a 0. Anything over 0 gives you an undefined answer. So, but instead of doing that, there are ways with which we can do it. If you actually factorize the numerator, if you factorize s squared minus 2x minus 3, what are the factors? Minus 3, two numbers that if you add together, you get this. If you multiply, you will get this. Minus 3 plus 1. So if you add this, if you include this one, you are familiar with the concept of factorization now. You have s squared minus 3x minus 1x minus 3. And that gives you x is common, x minus 3. Then what's common here? 1 is common, x minus 3. So I'll be having x minus 1, x minus 3. That means I can replace this one with x minus 1, x minus 3. And I'll be having the limit where s take to 3 of x minus 1, x minus 3 over x minus 3. So if x minus 3 cancels x minus 3, then I will take the limit. So the limit end up giving me 3 minus 1, which is a 2. So I believe there's no problem on that as well. So we have been able to reach conclusions, solve problems relating limits. Now, let's see the last one. Yes, that last one, you need to understand the concept. If you have any question as per the last one, just message me directly. Now, the limit of s take to infinity of 2x cubed plus 1 over 2 plus x minus 3x squared. Minus 3s cubed, sorry. So how do I solve this one? All you need to do is, at this point here, you must know that the limits where s take to infinity represents 1 over whatever highest power of x you are having there. So the highest power of x here is 3. So that means we can write this one as the limit where s take to infinity of 2s raised power 3 divided by x raised power 3. Since s raised power 3 is the highest power, plus 1 over x raised power 3 over 2 over x raised power 3 plus x over x raised power 3 minus 3x raised power 3 s raised power 3. And this one gives us s raised power 3 cancels s raised power 3. We'll be left with limit of s take to infinity of 2 plus 1 over x raised power 3 all over 2 over x raised power 3 plus 1 over x raised power 2 minus 3 as well. Are you with me? So if we now decide to take the limit of s take to infinity, we are going to have 2 plus 1 over infinity raised power 3 over 2 over infinity raised power 3 as well, plus 1 over infinity raised power 2 minus 3. And that becomes 2 over negative 3. That's minus 2 over 3. So you have the last one. Do that one, attempt it, then you can actually drop the comments on my comment section. You understand? So thank you, and I look forward to hearing from everyone. You understand? You can give out your opinions. It's a free world. Thank you, and thank you again.